GATE 2018 Civil Engineering Set 2 Question 54. A 7.5 meter wide two-lane road on a plain terrain is to be laid along a horizontal curve of radius 510 meters. For a design speed of 100 km per hour, super elevation is provided as per IRC 73/1980. Consider acceleration due to gravity as 9.81 meter per second square. The level difference between the inner and outer edges of the road needs to be found in meters up to 3 decimal places. The relevant NPTEL reference has been cited. When it comes to the design of super elevation for a roadway facility, the outer edge of the road is raised with respect to the inner edge. This is done so that the vehicle is able to counteract the centrifugal force acting on a curve and the passengers inside do not feel jerk. The first step that is done is we design the super elevation for 75% of the design speed. In this step, we calculate the super elevation using the equation v square by 225r, where v is in kilometers per hour and r is in meters. If this calculated value is less than the maximum value of super elevation that is applicable, which is 0.07, we provide the value of ecal. But if this value turns out to be more than 0.07, what we do is we go to the second step where we provide the maximum super elevation, that is 0.07, and calculate the coefficient of friction, which is given by F equals v square by 127r. Here we consider the full design speed minus the maximum super elevation, that is Emax. In case the value of F is less than the value of F maximum, we can conclude the design here, but if it turns out to be greater, we go to the third step, that is we find the allowable speed, which is given as va square by 127r equals E max plus F max, that is 0.22. Using this we can find the allowable speed Va. These are the design steps which need to be followed for designing of super elevation of a roadway facility. So in this case, the design speed has been given as 100 kilometers per hour, radius is given as 510 meters. So using step 1, that is considering 75% of V, we calculate the value of super elevation, which is v square by 225r. Here v is substituted in kilometers itself, 225 into r, that is 510. This gives out the value to be 0.087. We can see that the calculated value is greater than the maximum value. So what we do is we will provide Emax, that is equal to 0.07. We do not need to go to step 2 because the question instructs to find only the level difference between the inner edge and the outer edge, which is simply the super elevation multiplied with the width of the road. So there will be certain value of F which can be found using the equation v square by 127r minus 0.07, but since this value is not needed here, we won't be calculating it. The question instructs to find the height difference between the inner edge and outer edge, which will be given as the product of super elevation applied into the width of the road. So we are providing 0.07 super elevation here, and the width of the road is given in the problem as 7.5 meter for a two-lane road. This would give out the value to be 0.525 meters. So the level difference between the inner and outer edges of the road was found out as 0.525 meters for the roadway facility. The relevant NPTEL reference has been cited.